Hello, and welcome to Module 7.1, Graphing Systems of Equations. Our objective for today is that I can determine the number of solutions of a system of linear equations, and I can solve systems of equations by graphing. So, our vocabulary words today. A new one that we're going to introduce is consistent, and you're going to see it in this textbook. You may see it on standardized testing, but what that means is it has a solution or a system has at least one ordered pair that satisfies both equations. Now, so far we have only been finding one singular solution to a system, and there are other possibilities of possible equations that you could use in which you would have more than one solution, but less than the infinitely many that we have gotten already. And I want you to take 10 seconds to try to brainstorm in your own mind what one of those possible equations or graphs of an equation could possibly look like that you would have more than one place where it would cross any other equation or line. Now that you've thought about it for a little bit, the answer is if it is a quadratic. So if it is a curve, if we had a line like this and a line like that, now you're going to have two solutions for that system of equations. So that is just a kind of a little informational thought. We're not going to be working with that kind of a system at all this year, but that is something you may face in the future. Now, the most common thing that we have seen in this unit so far is one solution. And you can refer to these as being independent. And it's when your graph intersects at one point. And the key here is you have different slopes. So if you have two equations that have two different slopes, they will intersect at one point. It might not be a clean point, it might not always be a point on the graph, but they will always intersect at a point. Now, our next one, we have infinitely many solutions. We've seen that before. This is a dependent outcome. And in this case, the graphs are the same lines. So we have same slope, same y-intercept. And lastly, we have no solution or inconsistent. Your graph does not intersect. They are parallel. So we know that means same slope and different y-intercept. So we're going to use those definitions in example 3 and 4 here, where we're identifying the number of solutions that a system may have. So the first one we're going to compare, we have y equals x and y equals x plus 2. So my slope for the first one is 1. My y-intercept for the first one is 0, because x plus 0 is there. My second equation, we have a slope of 1, and my y-intercept is 2. So those have the same slope, but different y-intercepts, so it is no solution. Now, letter B, we're going to need to solve that first one and get it into slope-intercept form, so we're going to subtract x from both sides, and we get y is equal to negative x minus 1. And we see we have on the right side y equals negative x minus 1. Well, that's the same slope and different y-intercept. So it is IMS. It's same slope, same M, same B. Our slope and our y-intercept are the same. All right, you guys are going to try letter C and D, and then come back and check your work against mine. All right, letter C. We have 2x plus 3y equals 6. So we're going to start by subtracting 2x from both sides. And we are going to get 3y equals negative 2x plus 6. And then we divide by 3. And y is going to be equal to negative 2/3 x plus 2. And our other one, we're going to subtract 2x from both sides. And we get negative y is equal to negative 2x minus 2, and then we divide by negative 1, you get y equals 2x plus 2. So they do have the same y-intercept, but that doesn't matter. And actually, it does kind of a little bit. They have different slopes, so this is one solution. It has one solution to that. And ironically enough, it will be at the y-intercept of 2, because that is a place that they both have in common. All right, letter D, we're going to start. We're going to add x to both sides. And we get that y is equal to x minus 1. And we have y is equal to negative x minus 1. So this is also going to be one solution. So you have two different slopes, and that's all you need to know. So our process for solving by graphing. How do we go about doing this? The first thing we need to do is identify what is my slope and what is my y-intercept of my graph. So my slope in this one is a 3, and my y-intercept is negative 5. And in the second equation, my slope is negative 2, and my y-intercept is positive 5. So we're going to use this information on the next page. And you're also going to see as I go through these notes, I'm going to be doing these in two different colors. That way we are consistently seeing the difference between the two pieces of information. So on the next page at the top, we have our grid. And my first line, the top line, my slope was 3, my y-intercept was negative 5. So I'm going to put a point at negative 5. And my slope is 3, so I'm going up 3 and to the right 1 with each step. All right, so we're reviewing back from when we did graphing. Our slope is always up, either up or down, up if it's positive, down if it's negative, and we are always going to move to the right from that point. So now I can go ahead and I can draw my line in. Remember, the expectation is that there's arrows at the end of it. Now, my second equation had a y-intercept of positive 5, and it has a slope of negative 2. So it's going to go down 1 and to the right 2. And now, because I have that line drawn in there, it won't let me put a point there. But you can see I would have a point right there. And I'll continue my pattern on beyond that. So we're going down 2 and to the right 1 with each step, since it is a negative 2 slope. And we draw our line in. Now, this is going to be easier for you guys doing this on paper, in that you don't have to worry about lining up dots. It's a little harder for me digitally. So now we are looking for what is the coordinates. Where am I crossing this point? That's going to be right there is where those two graphs are going to intersect. And that's at the point 2, 1. So as we have for everything in this unit, we can check our work. So we're going to substitute in 1 for y, and we have 3 times 2 minus 5. And we have 1 is equal to 3 times 2 is 6 minus 5. 1 equals 1. So it checks out on the first equation. Substitute it into the second equation. Negative 2 times 2 plus 5. Negative 2 times 2 is 4. So that's negative 4. Plus 5 gives you 1. So 1 does in fact equal 1. So our equation, or our point, checks out. It verifies that we are correct in our thinking of what it is. All right, so let's look at letter A. Letter A has y equals 2x minus 4. So my slope is 2. My y-intercept is negative 4. So let's go ahead and graph that one right away. So we have a point at negative 4 is where I'm starting, and my slope is 2, so I'm going to go up 2 and to the right 1. And you really want to make sure you are precise with your points, or as precise as you can be, because if you start to drift a little bit in your points, you are going to get the wrong answer, because we are graphing this, and so we need precision. We need these lines to be exactly where we want them to be so that we can see if they intersect. Now, my next one, my slope is negative 1/2, ooh, a fraction, and my y-intercept is 1. So I'm going to start off at the point 1, and I'm going to go down 1 and to the right 2 now. Negative 1, we go down 1, and we always move to the right. So we're going to move to the right 2. And again, I can't put the line right on that point, but you can see that's where it would be. And then I move again, down and 2, down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. And I'm going to change the thickness, and I can draw in my line. And so, obviously, when we look at these, we can see where we intersect, and it's that point right here. And that point, the ordered pair, because that is the ordered pair is the actual solution of an equation. So that is what you need to write your ordered pair, your x and y coordinates. All right, let's look at letter B. Now let's change our colors up and look a little different. So we've got y equals x minus 5. My slope is 1. My y-intercept is negative 5. My second one, my slope, is negative 2. And my y-intercept is 4. So we go ahead and graph the first one. We're starting at negative 5. And we are increasing. We're going up by 1. So we're taking a step up 1 every single time. Now, remember when you are graphing, my minimum is bare minimum is to have 3 points. My ideal, I would like you to have 5 points or more if you can. In this case, I did a whole bunch there. I did 10 points. All right. Now, our second equation, we're starting at a y-intercept of 4, so we're up there, and we have a negative 2 slope. So we're going to go down 2 and to the right 1. Down 2, right 1. Down 2, right 1. I can't put it right there, but it's there. Down 2, right 1. Down 2, right 1. Down 2, right 1. Down 2, right 1. And again, we connect our line, connect our points. And we see where they are intersecting. It is very clear. It's the point that I couldn't put a point on right there. And our point is at a positive 3 and negative 2 for the y. All right, so this isn't a really radically different concept than what we've been doing. You're just now graphing 2 lines on the same grid instead of just 1. All right, so now you're going to go ahead and you're going to go to the next page. And there are 2 U-try problems. I would like you to graph those on your own and find the solution point, and then come back and check your work against mine. All right, letter C, first equation. Slope is equal to 2. My y-intercept equals negative 1. And my second equation, my slope equals negative 1. My y-intercept is 5. So let's graph this. My b value is at negative 1 and a slope of positive 2. So I'm going up 2 and to the right 1 with each step that I take. And we're only going up 2, and we're able to use the grid because of the fact that my grid is just a scale of 1. So that's something you always want to look at is what is the scale of your grid? So my grid is 1, so I'm going up 2 boxes and to the right 1. All right, the second part of this, the green line, we're starting with a point at positive 5, and the slope is negative 1. So I'm going down 1 and to the right 1 with each and every step that I take. And you see this consistently walking our way through, and we have our point right there. To close it out, then I'm going to draw my line with. And a little off on this line. So we're going to just drag it over a little bit. There we go. That's a little bit better. And this end just needs to be adjusted a little bit as well. All right, so you can see, though, where you are crossing is at positive 2, positive 3. That's the ordered pair that you're crossing at. Letter D, we have y equals x minus 2. My slope is 1, because there's a 1 in front of the x there. And my b value is negative 2. All right. my second one, my slope is -2, and my b value is 1. So a little bit of a role reversal there. So we start off, b is -2, so we're at -2, and our slope is 1, so we're gaining 1 every single step that we take, all the way to the edge of the grid, and we can draw our line in from there, and we've got our nice grid, or nice line. Next one, my b value is 1, and we are going down 2 and to the right 1, so a -2 slope, so we have a point there. We have a point right there, down 2, 1, down 2 over 1, and down 2 over 1. And when we draw our line in, we see that we are crossing right here. The ordered pair is 1, -1. All right, now, you might be asking yourself, what if the rare occurrence that Mr. Boland does not give you a line in slope-intercept form already? What do you do? Well, the first thing you should do is put it into slope-intercept form, because we want to graph these. So for the left one, we're going to subtract 5x from both sides, and we get 3y equals -5x plus 9, and then we divide by 3, and we need to divide all 3 parts by 3, so y is equal to -5/3 x plus 3. And we can rewrite that right here. Y equals -5/3 x plus 3. My second equation, I'm going to start by adding x to both sides. 3y is equal to x minus 9. And then we divide by 3 all of our parts. We get that y equals, we're going to write it as a fraction, 1/3 x minus 3. So y equals 1/3 x minus 3. And I made the same mistake by duplicating my writing there. So we're just going to shift that over. So we've got y equals -5x plus 3. All right, so now we're back to exactly where we started today. We are finding our slope, which is -5/3. We're finding our y-intercept, which is 3. And we're doing that for both equations. The second equation is 1/3 with a b value of -3. All right, so we're going to go to our next page, and we're going to graph them. So we're going to start with the red equation. The red equation had a y-intercept at +3, and it had a slope of -5/3. So we're going to go down 5, 1, 2, 3, 4, 5, to the right 3. Down 1, 2, 3, 4, 5, to the right 1, 2, 3. Okay, and we're going to draw our line based on that. Okay, and I'm going to have to fix this bottom end here because it didn't go all the way to the edge of the grid. So it's a lot easier for you guys when you just use a ruler and are able to just draw it out. All right, there's my line there. And my second equation had a y-intercept of -3 and a slope of 1/3. So I'm going up 1 and to the right 3, up 1 to the right 1, 2, 3, up 1 to the right 3. That was 2. Up 1 and to the right 3. That's better. And again, we're going to draw that very shallow line. And we are seeing that we are going to cross right there. And that point is going to be 3, -2. And we're going to check our work. And for this one, we always want to go back to the original equation when we check our work. So we have 5 times 3 plus 3 times -2 equals 9. 5 times 3 is 15. 3 times -2 is -6. 15 minus 6 is 9. And that checks out. You always go back to the original equation because if you possibly made a mistake, you could catch that mistake by looking at the original equation instead of what you had already solved. So if you had made a mistake solving 4y, you can catch that mistake by going back to the original all the time. So we have negative 3 plus 3 times negative 2 is negative 6 equals negative 9. Negative 3 minus 6 is negative 9. And so it checks out in both equations. All right, I need you guys to go ahead and try letters E and F on your own. And then when you are done with them, please come back and check your work against mine. All right, letter E, my first step, I need to add 2x to both sides to get y by itself. And I get y equals 2x minus 4. And my second equation is already in slope-intercept form, so I don't need to do anything with it. So slope on the first one is 2. My b value is negative 4. So we have a starting point at negative 4. And our slope is 2, so we're going up 2 and to the right 1 with each and every step that we take. Up 2, right 1, up 2, right 1. And we have our graph of that line. Arrows at the end, nice and good. All right, now my second equation, I have a slope of negative 1/2, and I have a b value of 1. So we're starting at positive 1. We're going down 1 and to the right 2, down 1 and to the right 2 with each step that we take. Down 1 and to the right 2. That takes us to the edge of the grid. And now we can draw in our line. Okay. And we see that our intersection point is right there, and the point is 2, 0. All right, letter F. The first equation, we're just going to add x to both sides. And we're going to get y is equal to x minus 5. So my slope is equal to 1. My y-intercept is negative 5. My second equation, I'm going to subtract 2x. And I get y equals negative 2x plus 4. So my slope is negative 2. My y-intercept is 4. So let's graph these. My first point is at negative 5, and it is a positive 1 slope. So we're going up and to the right with each step that we take. We're going up 1, right 1. And once we hit the edge of the grid, I can draw in my line. And our second one starts off at 4 on the y-axis, and it has a negative 2 slope, so we're going down 2 and to the right 1 with each step. Okay, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. And I connect my dots. And I have my line. And my point is where I intersect, and that is at 3, negative 2. All right. So let's take a look at our next page of these notes. Example 7 is writing a system of equations. So first off, we need to break apart the word problem and figure out what it's telling us. So one satellite radio service charges a $10 per month plus an activation fee of $20. Another service, a second service, charges $11 per month plus an activation fee of $15. In what month was the cost of the service the same? So what am I trying to find? I'm going to try to find when these two equations are going to be equal to one another. So my first line, the red equation, we're going to have $10 per month. So y is equal to $10 per month plus $20. So $10 per month times 10 months plus $20. my second equation, y is equal to, it's going to be $11 per month plus $15. And I probably should have defined my variables over here. X equals month, y equals cost. Okay, so I did define them on my graph. So I have my units labeled. Months are on my x-axis. Dollars are on my y-axis. My x-axis moved at a rate of each line is 1, so my scale was at 1. I only labeled the even months. My y-axis, I went up by 5, so every line is $5. And my I only labeled the odd values. So now my first equation, 10x plus 20. So we start off with a point at 20. And it's going up $10. The slope is 10, but we need to pay attention to what our scale is going by because each line is $5. So going up $10 is going up 2 lines only. So you do need to pay attention to your scale, especially when you're dealing with word problems. This has gotten us into trouble before. So in this case, since the scale is going up by 10 or 5 each step, we are going to go up 2 boxes. And now, since this is a real world problem, I am only going to have an arrow on the end of it, on the right end, because your cost cannot be negative. The satellite radio is not going to pay you money if you have negative months using their service. All right, now the second one is a little trickier to graph. We're starting off with a y-intercept at 15, which is not tricky in itself, but the slope is 11, and I've got a grid of going by 5s. So you're going to have to do some approximating. So it's going to go up 2, and then it'll just be a little bit above. And then it's going to be just a little bit above, going up 2 grids again. All right, we're going to see if we can move that line off to the side and see if it'll be a little easier. All right. So it's going to be like that, and then like that, and then like that. And then we're going to be a little bit above there. Oops. So we're going to be a little above there. We're going to be a little further above, and then a little further above. And then by the time we get to 8, we're going to be a bunch above. All right, so now I'm going to bring the red line back into where it was. And I'm going to draw in a blue line, or green line, sorry, green line. And we're going to have that arrow. And where do these 2 grids cross? Right there at the 5th month? Nope. They cross in the 4th month. No, they're close in the 4th month. It's actually the 5th month where they hit. The green line's a little bit off of where it should be because it should be right there. So our 5th month is the one that should have them intersecting. Now here's, why did I do this? Why did I use this really random scale? Why did I do this? The reason I did this was because graphing requires you to be incredibly precise. So the advantage of the graphing method is to identify numbers of solutions easily, especially if you're able to use technology to your advantage and use a graphing calculator or a graphing program. This one is a challenging one to be able to find that intersection point just because of the fact that we have a difference of 1 in our slope in numbers that really don't allow us to do anything other than going by 5s. So at 5 months, we are going to be equal, and if you are interested, it would be, those 2 plans would be equal at $70 at that point. You would have spent $70 on either plan. All right, our second example. We're not going to do it as a U-try, we're going to do it as a group. So our second example, we have one puppy that weighs 5 pounds at birth, and it grows at a rate of 0.25 pounds per month over the first couple months. We have a second puppy, and the second puppy weighs 4 pounds at birth, and it grows at a rate of 0.5 pounds per month. after how many months will the puppies weigh the same amount? So we want the intersection point of where the puppies are going to be. So our first line, our first equation, are y. So let's define our variables. Y equals pounds and x equals months. So y is equal to our rate 0.25 times the number of months plus the 5 starting pounds. Our second equation, the weight is equal to the rate 0.5 times the number of months plus the starting 4 pounds. All right, now if you look at my graph, I already gave you the units on it. My x-axis is measuring months, and I'm going by ones, and I labeled the odd values. My y-axis is measuring the pounds of the dog, and I'm going by a half a pound interval, and I only labeled the full pounds going up. So the red equation starts out at 5 pounds, and it's going up by a quarter of a pound each month. Well, if I look at it, quarter of a pound in a month is going to be halfway on that grid line, and it's going to take 2 months before we go up a full pound. So every 2 months, we're going up a full pound. Okay, and that one went a little more. So every 2 months, we go up a full pound. Okay, and that's our line there. Okay. Right? Nope, those are not our points. 1 month we're going up, we went up half a pound. I went up way too much. So if we're going up a quarter of a pound a month, it'll be 4 months before we actually go up a full pound. So we're going to be halfway in between. And this is, again, I look over the graph and I look to see, are my values where they should be? Does it make sense with the information that we're given? So we're only going up halfway on that grid. So that is a much cleaner, much better line. All right, now my second one, we have y equals 0.5x plus 4. So we're starting off at 4. Now we're going up the full half pound. So we're going to go up one grid line with each and every one of our intervals. And so then we have a grid there. It's a little off, but that's just because of not being able to write where there is a line drawn in. And we draw our line in. And there we go. We have our intersection point. So at 4 months, the dogs will be the same. And if you are interested, it will be 6 pounds. All right, now our final two graphs are going to be systems with infinitely many solutions or systems with no solutions. So my first one, I have a slope of -1. I have a y-intercept of -3. So let's graph that. And we have a point at -3. And we're going to go down one and to the right one with every step that we take. And now when I go ahead and I draw that in, we have our line. My second equation, my slope is -1 and my y-intercept is 5. So we're starting off at 5 and we're going to go down one and to the right one with every step that we take. And we draw our line in, and there we go. You can see we are parallel. We are never going to cross. So this is no solution. Our second example, we have y equals 3x minus 3. My slope is 3. my y-intercept is -3, so I put that point at -3. And my slope is 3, so I'm going up 3 and to the right 1 with each and every step I take. My second equation, I'm going to divide all 3 components by 3, and I get y equals 3x minus 3. So I put my y-intercept at -3, and I'm going up by 3 each and every time. And so what I end up with is, ooh, I'm going to do, yeah, actually we will do that one as the bigger one. So we have that line there, and we have that line there, and you can see they are the same line, so that's infinitely many solutions. All right, that is our notes for today. If you have any questions, please bring them to class tomorrow. Otherwise, I hope you have a great day.